Today we will talk about kitchen ventilation and air conditioning system. Okay, both we will look into that calculation part.
Sure.
Okay, there is one standard for the kitchen application. Okay, you can see DW 172 kitchen ventilation system.
Okay.
Clear. So this
Yes.
this
Yes.
this particular code we will use it for to design the air conditioning system and as well as ventilation system for the commercial kitchen, not for the small like pantry or residential kitchen, which is not required. Okay, this is mainly for the
Okay.
heavy cooking. You can see the picture where they do the heavy cooking with like for large meals, right?
Yes. Yes.
Okay, such condition we require proper air conditioning and ventilation system. Okay,
Sure.
so I have some guideline where you can go through. Okay, you can see that a well-run kitchen not only require a dedicated staff, it also takes a well-designed HVAC system. If the kitchen doesn't have a proper air conditioning, extract and makeup air unit, it can make working in the kitchen more dangerous and create a domino effect to everyone exposed. Okay, so this is the reason we are going to do proper air conditioning and ventilation system. Okay, so if you go through the chapter, if you go to ASHRAE chapter 28, they talk about non-residential heating and cooling load calculation where we do normally the thermal load calculations, right? And if you go
Yes.
through DW 172 where they talk about kitchen ventilation system. So for this particular uh, calculation part, we talk more about DW 172. Okay, so if you go to
Okay.
one of the building, one of my previous project where you can see if you talk about any of the kitchen, okay, kitchen
Hmm.
layouts which consist of
Yes.
main kitchen, special kitchen, bakery area, then you can say that dishwash and pot wash area, then veg
Hmm.
preparation area, then you can see the cold
Hmm.
storage area. So this is like a more common uh, sub
Number of
rooms.
spaces
Num,
that
num,
typically be there in a massive kitchen. Correct.
yeah, number of spaces. Okay, so you can see
Yes.
that main
Yes.
kitchen where they do the main special main activities, then special kitchen where they do the special kitchen activities, then bakery area. Okay, then
Yeah.
the dishwash area, something like that. Okay, so this is the
Understood.
most of the project you have a sub rooms. Okay, okay.
Hmm.
Now if you go through the DW 172, okay, all areas shall be air conditioned. So if you talk about one of the layout where if I go through, if I go below previous slides, okay, you can see there are some of the typical kitchen layouts, right, where you can see this is the you can see main kitchen, right, main kitchen where they do the main cooking activities. Okay, so you can see there are number of kitchen appliances, right, which is required for cooking for that particular meals. Okay, maybe the meals may be Indian or Arabic or Italian cook, Italian or whatever the type of foods. Okay, so
Yeah.
that,
Yeah.
that there will be kitchen consultant who will design the layouts. Okay, so he will
Uh-huh.
decide what are the appliances required for particular meal. Okay, so maybe you
Hmm.
cannot take typical appliances may not cannot be used for different type of cooking appliances, right? So there are
Understood. Yeah.
different appliances will be selected by the kitchen consultant for that particular type of meals. What are the kitchen appliances required? Clear. Okay,
Yes.
now based on that he will create the layout. Okay, so there are different layouts. Okay, so this what they are trying to say, all areas shall be air conditioned.
Hmm.
Okay, if you go below the slides.
Yeah.
So first condition is all areas shall be air conditioned to maintain proper air temperature. Okay, to maintain proper comfort cooling. Okay, say for example, all
Yes.
the temperature should be within 25 plus or minus 1 degree Celsius. So if you go through the standard, even if you go to kitchen standard, there are a lot of pages. Okay, this is like a short. Okay, whatever we have selected the important point and we have
Yeah.
highlighted here.
Important points.
Okay, yeah.
Understood. Yeah.
So the temperature you can say that approximately like 25 plus or minus 1 degree Celsius, which is for cooling comfort. Okay, for the human comfort requirement. Okay,
Yeah. The cooling set point, right?
yeah, cooling set point. Okay,
Yes.
then all air conditioning will be designed considering all the factors like lighting load, occupancy load, solar heat gain through walls and roofs, partition load, and mainly heat dissipation from the kitchen equipment. So when you do the heat load calculation, it is like normal for other buildings like residential building or commercial building. Okay, like normal how you do the heat load calculation, you will do the same
Yeah.
heat load calculation
Same
here
heat
as well.
loads have to be
Yeah,
assumed.
but
Yes.
only the difference is mainly the heat dissipation from kitchen equipments.
Okay.
Okay,
Understood.
so I will open one of the sheets. Okay, where you can see, say for example, this is the kitchen room data sheet. Okay, where you can see different the different like serial number, the description of the items. Okay, the quantity
Hmm.
of the items, and there is a make. You have a different makes. Then you can see the image type of appliances, right? Okay,
Okay.
whether it operates by gas or by electrical. Okay, Then what is the electrical requirement, okay, for the power requirements. Then what is the quantity, okay. Then you can see that what is the design temperature requirement for that particular rooms, and for the ventilation requirements, if any, in that particular room. Then what is the heat dissipation per unit, total heat dissipation from the kitchen appliances, okay. So these all the data will be available in this room data sheets, okay. You can say different type of appliances like cooking kettles, okay, chapati machines, okay. Then you can say
Yeah.
combi, oven, rotary. There are different type of appliances, okay. So you can see the heat dissipation per equipment, which when it operates, you can see that 8500 BTU per hour will be the heat dissipation, right.
Dissipation. Yes.
Let me, yeah, you can see that heat dissipation for this particular appliances 8500 BTU per hour, okay. And for this particular appliances like a proving champer 9830 BTU per hour, this is a heat dissipation from each
Yes.
equipment, okay. So when you talk about one room, when you want to design for one room, assume that there is a main kitchen, okay. So in the main kitchen you have a different appliances, right. You have appliances
Yes.
like rotary rack, oven, then proving champer, automatic duff sheeter. So you have a different equipments which you have a consist of total heat dissipation inside that particular room, okay.
Yeah.
So when
Yeah.
you multiply by equipment, you will have a total heat dissipation. So this particular heat dissipation will be used in the air conditioning calculation when you do the thermal load calculation in the HAP software.
Yes. But this is basically for the main kitchen. This is the 14 numbers that you've shown us basically all of the equipment in one particular kitchen. So we have
One
to total
particular,
the end. Yeah.
yeah, yes, correct.
In one kitchen, and then you have to basically take a summation of all of the heat loads that are there in this. But I have a question here. So, for example, you've shown an example where you have a kettle shown. So in the
Okay,
kettle and all, we know that, right? After a certain point, you'll have steam generated from these kettles, like
yeah,
hot water. So
yeah.
basically, that is not it's not sensible load, right? Do you
It
get
is a
where I'm
latent,
coming from?
yeah, it is
It's
a
latent
latent
load,
load.
right? It's
Yeah.
latent load. So my question now is that not accounted in this data sheet when they say that, or generally, or is it something? How do we consider that in the heat loads, or do we just reject that particular load?
No, see, if you go to the particular data sheet, they might have mentioned that what is a sensible load and what is a latent load. If there is any latent load
Okay.
like steam or something, they will be
Yeah.
mentioning. So when you enter in the heat
Okay.
dissipation, remember there is a miscellaneous load in the thermal load in the
Yes.
HAP
Yes.
software. So in the miscellaneous load, you can enter what is the latent load.
Sensible and what's the latent?
Yeah, latent load. That is what that particular column is given. Okay. So
Yeah.
if you have any additional sensible or if you have any additional latent, you can able to enter the values here. Okay, whatever the latent and whatever the sensible.
Yeah.
Okay. But this is a heat dissipation from the equipment. Basically, this is where we used to mention the electrical equipment dissipation data, right?
Yes. But this is also as part of your sensible miscellaneous load, right?
Yeah, this is also part of the sensible miscellaneous load. Yes.
Got it. Yeah.
Yeah. Okay. Okay. So similarly, like you have a special kitchen. Okay. Then you have a cold kitchen. Okay. Then you'll be having veg preparation area, different areas, different equipment, appliances. You have a different heat dissipation. So that will be counted when you do the HAP calculations. You're
Yep.
clear, right?
Mhm.
Okay. So now this is very simple. Air conditioning is not a big deal. You do the air conditioning calculation similarly to like how you do the other rooms. Okay. But only the main parameter you have to consider what is the design temperature to be maintained inside the kitchen area and what is the heat dissipation from the kitchen appliances. So that two parameter you have to consider when you do the calculation, air conditioning calculations.
Yes. Understood.
Okay. Now the main subject is the kitchen ventilation system. How we do the ventilation system for that particular rooms. Okay.
Mhm.
Okay. So here you can see the kitchen ventilation system. An adequate kitchen ventilation system is to ensure the following: kitchen area are designated as negative pressure rooms because whatever the fumes or whatever the heat, okay, excess heat should not be thrown outside the room, right?
Yes.
Okay. So
It should
that
be
is why
thrown
we
outside.
maintain negative pressure. Okay. So you can see that the purpose of the negative pressure is to remove cooking fumes at the source that is close as possible to the cooking equipment, right? Then remove excess hot air and introduce cool clean air, maintaining a comfortable environment. Okay. Inadequate ventilation can cause stress, contributing to unsafe working condition and high staff turnover. So this is why we do proper ventilation. Okay.
Yes.
Ensure that air movement in the kitchen does not cause any discomfort. Provide sufficient air for complete combustion at fired appliances and prevent the risk of carbon monoxide accumulation. So this is also similar to the generator. Remember, we provide oxygen inside to the
Yes.
generator room, okay, for the combustion.
Yes.
Similarly, there is a requirement of fresh air for the complete combustion of fire appliances. Okay, if you
Okay.
don't have proper oxygen, maybe it not possible to uh, operate your equipments, right?
Yes. Yes.
Okay, okay. So this is one of the main important subject for the kitchen ventilation system. If you go to DW 172 for the kitchen ventilation system, okay. So if I go
Yeah.
further down, okay, you can see one of the picture where the proper extraction from the inside the room, right? This is the hood,
Mhm.
okay. Then you have appliances, okay. So it will be directed towards the your what all the fumes will be directed towards the canopy, so that there will be no heat will be it will be surrounded in that area, okay.
Understood. Yes.
Yeah. So this particular calculation will be done by based on thermal convection method. Okay. Say for example, if you go to fresh air calculation, we do based on ASHRAE 62.1, right? To maintain
Yes.
indoor air quality. Okay.
Yes.
Similarly, for kitchen, we do based on thermal convection method. Okay. So this is the calculation method we will follow for the kitchen ventilation system. Okay.
Okay.
If I go down
Um,
further, okay. Yeah. Tell me. Yes.
yeah. So, but my question is now, sorry to cut you here, but this is when it comes to a residential application, generally the kitchens in the residential application, I know you said it's not applicable, the DW 172 standard is not applicable. So instead we use the ASHRAE requirements, what's there for kitchens and everything in the 62.1 when we're doing a ventilation for the kitchens in the apartments, correct?
Yeah. That is for light cooking.
Light cooking, yes, light cooking. Okay,
Yeah.
thanks.
Clear, right? Okay. See, now you can see that there are different appliances. Okay. You can see different appliances like benches, spread, worktops, sink, okay, coffee maker. There are different appliances they have already provided in the data sheet. Similarly, when you go to fresh air calculation, they have given the different occupancy category, right? Or building category. Okay. Similarly, here in this DW 172, they have given the different type of appliances where you can see benches, spread, coffee maker, refrigeration unit, okay, bread pan, okay, different type of pasta cooker, okay. So each equipment is having a coefficient. You can see that appliances and then the coefficient and temperature schedules, okay, where you can see the coefficient factor, okay.
Okay.
Okay, this is the coefficient factor for each of the equipment, okay, how it's operated. Like you can say like efficiency of the machine, okay. It's not efficiency, basically it is a factor, okay, you are going to apply. Say for example, say for example, when there is appliances, okay, when the appliances dissipate a heat, okay, it will be like through surrounding, okay. So when you have extraction, you're going to have a extraction on the top of the appliances, right? So there is
Yes.
a chance of spreading, some fumes will be spreading towards outside, okay. So you're going to
Yes. To the
collect
nearby
yeah,
spaces. Correct.
yeah, nearby spaces. So what you are going to do, you are going to apply factor to, so that you can increase the ventilation airflow rate, so that you can suck proper more air volume, okay, so that you will not try to dissipate heat. Clear, right? So
Understood.
that is why this is one of the value they have given, like coefficient and temperature schedule. What is that? What is the temperature, expected temperature on the top of that particular appliances, okay, and what is the coefficient factors for if it is a gas or if it is electric, what is the coefficient factors. So they have provided the table here for all the appliances. Clear, right?
Yes. Yes.
Okay. Now if you go to the other one, okay, okay, you can see here there are type of canopy factors. Okay, depends upon the that canopy locations. How you going to mount the kitchen canopy, like the hood. Okay, whether it is a low level or pass over or overhead wall or overhead wall island mounted or island. Okay, and then
Okay.
the ends, like if you see the ends which is open, both ends, okay, or
Mhm.
open one ends and one end will be closed, or closed to both ends, right? So when you go down here, you can see the different type of the canopy arrangements. Can you see the wall mounted canopy? This is the
Yes.
appliances, you can see the wall mounted, right?
Yeah.
Okay, you can see the single island single-sided island canopy. Okay, where you have appliances and where you have a canopy in the center of the room. Okay, where you have a single side. Clear?
But when you mean single-sided, um,
Yeah, you can see this picture for both sides. So the people can
oh, okay,
operate
you
from
mean
both sides.
okay. Sorry. Okay, basically, the difference between these three are basically the operate. It's from a difference between an operator's point of view as well. So
Yeah,
if a
point of
person needs
view.
to put,
Yeah.
yeah, okay, understood.
Okay, so this is the complete canopy you can see here. Okay, where you can see the appliances. This is like both side double sided, and this is single sided. Okay, where you can see the low level wall mounted canopy, right?
Yeah.
Okay, and then you can see that eyebrow canopy with open bell mouth connection and woven. Okay, like this you might have seen in some restaurants where the Arabic grill restaurants where they prepare the Arabic grills and all. Okay, so this type of canopy they have might have used, right? Type of appliances. So where this type of appliances, what is the type of kitchen hood and what is the canopy factor? So each and every depends upon the location, the canopy factor will vary, right? Okay, you
Okay.
can see the dishwash canopy with the grill, then dishwash canopy with the condensed drain, right?
Okay. But can I
Okay,
ask you something? So for each of these applications, for example, okay, I mean, say you have a multi-cuisine restaurant, like how we have typical restaurants we have in the UAE. So it will be like for each so for each cuisine they won't have a separate kitchen, right? All of it would be in one kitchen mostly, right? Like I mean to say, like for cafeterias or anything of that sort, where you've got maybe a shawarma stand or maybe some Arabic food happening on one side, then the Indian food happening so it will be like the kitchen consultant will make sure those are all separate zones in itself, right?
yeah. This is why you can see the layout where you have a different hoods used for different type of cooking, right? You have one type of cooking here, one type of cooking here, one type of cooking here.
Okay.
So okay, so you have a different hoods.
Mhm.
Maybe this particular
And
main kitchen maybe consists of different type of
cuisines
uh,
or
yeah. So that is why you have
but
a
yeah.
different hoods. Yeah.
Yeah. So these foods will be put in particular to that particular cuisine. That's what the kitchen consultant's scope of works involves in, right? So, like for example, you said right for the grill foods or the Arabic grills that you said, they have a different sort of a kitchen hood
Appliances.
system,
Yeah, appliances.
appliances, and the kitchen hood as well in the
Yeah,
DW 170. You
yeah.
showed me the
Kitchen
last
hood.
example, right?
Yeah, yes, yes.
Yeah. Okay.
Okay.
Yeah.
Okay. Now, if I go back to the DW 172, okay, where you can see there are multiple appliances, right? You have a griddle, open drain stove, then you have a combi oven, okay, you have bench, you have a twin fryers, okay. Now, if you go further down, you can see the canopy sizing, right? When you do the canopy, like a kitchen hood, how to do the sizing, right? For example, when you have appliances, you should have a 250 additional extra from
On
the
either
space
side.
on either side,
Mhm.
right? Okay,
Mhm.
and when you see the front side, you can see like 250 again. Okay, so that means
Mhm.
all over you have to cover 250 Okay, and if you talk about there is other type of kitchens, okay, where you can see the Arabic type of cooking appliances where you have to maintain like a minimum 600 from the edge of the appliances to the canopy. You have a 600, right?
Yeah, 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 yeah.
Where you can see in this picture, okay, right? The rear space you're giving 100
No, no,
mm.
yeah, yeah. 100
Yeah, for the
for
space.
services.
Okay, so here actually, if you see other kitchen, they have other appliances. They have given only 250, but for this appliances 600 because the door has to open. Okay, to cover all the complete appliances, they have given extra 600
Understood.
Okay, so this is the
So
way
these
they
are more
size the
like in
canopy.
the you mean to say like those big, massive ovens, right? Where you have bread, so you have to open your door and basically take your food
Yes,
from the.
yeah,
That's the case you're saying, right? So
yeah.
in this
That's
section
the
right now,
case.
the doors are open, right?
Yeah, doors are opened. Yes,
That's why
yes.
the extra 600 you meant. Yeah,
Yeah,
understood.
extra 600. Okay, so that whatever the fumes comes from the appliances, that will be taken immediately. To avoid any surrounding, whatever the fumes should not be surrounded to outside. Okay, that will create an excess heat, so that then the human will get disturbed.
Understood.
Okay, so this is the sizing, how to size the canopy, right? Depends upon the appliances. Okay, so you can have a canopy sizing, right? Okay, when you go further down, further upside, you can see the thermal convection method calculation, right? You have a different type of items like you have a griddle, open top range, solid top range, benches, twin fryers, Salomon grill. That all you can see in the below pictures, right? Okay,
Yes.
so this is the sizing of the appliances, sizing of the canopy sizing. Okay, where you have a 250 extra here, and in the front side you have a 600 extra, right? Because of the this particular
Yeah.
open
Because
oven.
of the doors, the extra 600 is given.
Yeah, 600 is given. So this is the way you size the kitchen canopy. Clear, right?
Okay.
As per DW
Okay.
172. So when you
But
see any
generally,
of
do
the
we
kitchen,
have to size these canopies, Bundy, or is it the
it is
kitchen itself?
see, it is not required basically. It is by kitchen consultant, but we have a knowledge that how they are sizing, right?
We need to understand. Okay, if
Yeah,
the
yeah.
coverage is required.
Yeah,
provided
coverages
or-
are yes, because the appliances not selecting by us, right? And
Yes.
and based on the appliances, the canopy will be selected. Okay, but why you
Okay.
should know the canopy size and to understand to calculate our ventilation requirements, right?
Requirements. Yeah.
Okay. Now, if you see this table, you can see the different dimensions, right? For the if you go to the plan, you have a different dimensions of each appliances. Okay, it's provided here. Clear, right?
Yes.
Okay, then you can see whether it is power or electric
Mhm.
operated equipments. Okay,
Yeah.
and then you can calculate the area, just multiply by all the appliances, right?
Yes.
Okay, then you have a coefficient factor from the table for the whatever the particular appliances, you have a coefficient factor.
Okay.
Okay, so then you can see the flow rate, right? To calculate the appliances, multiply by the area, multiply by the coefficient factor, which will give you the total flow rate.
Flow rate. Understood.
Clear, right? Okay,
Yes.
and then
Yes.
you can summation of all the flow rate will be, you can say for example 0.135, 0.27, so and so,
Hmm.
and the total will be 1.123. Okay, then the canopy
Okay.
factor. Assume that you have an overhand wall open both ends. Both end open means like this is your canopy. Here you don't have anything. Here you don't have anything. Okay.
Okay.
So what is
Yeah.
one side? What is one side open or one side closed? Assume that you have a walls here. In the end of the canopy, you
Understood.
have a
Yeah,
walls
I
here.
think I was also about to ask you that. Yes.
Yeah, so
Understood.
that something like that, okay. Or you have a different something is obstruction, then it is called one side
Mhm.
open and one side closed.
Hmm,
Clear,
hmm,
right?
hmm.
Okay, then so
Mhm.
when you apply the depends upon the canopy factor, depends upon the type of canopy. When you apply canopy factor, assume that it is 1.125 as per the table. So you can get the total ventilation requirements. Okay,
Yeah.
for that particular canopy, for that particular appliances, right?
Particular set of appliances, right?
Set of appliances, yes. So if I go to the diagram again, okay, assume that I have a one of the layout, okay, where you have a different type of cooking appliances, right? You can see
Yes.
the appliances here. So now you know how to size the canopy sizes, right? So
Yes.
you can give 250 all around, 250 all
All
around,
around the
so that you can
equipments
size
that we
the
have.
canopy, right? And
Yes.
so you know the list of the appliances. Okay, say for example, as per the kitchen consultant, you have a list of appliances where you can take the coefficient factor, right?
Yeah.
Okay, and then when you use the thermal convection method, you can able to calculate the flow rate. Okay, for each appliances. For example, for the set of appliances here, you can able to calculate the ventilation requirement, and you can able to calculate ventilation requirement for this set of appliances. Similarly,
Yes.
for everyone, right? Okay.
Yes.
So when I go to one of the ventilation schematic diagram, okay, where you can see one of the main kitchen, okay, where you can see multiple hoods, right? Okay, so you can see that this is the exhaust, this is the requirement, and for the fresh air, we create normally 85% to create negative pressure.
negative-
okay, 80
negative
or
pressure.
85% depends upon the consultant. Some consultant use 80, some consultant use 85% to create negative pressure. Okay.
Yeah.
So this is the way you can calculate like a exhaust fan, exhaust airflow requirement for each and every appliances. It is calculated, right?
Okay.
Okay, then when you combine with the multiple hoods, okay, you can go with the one of the makeup air handling unit and one with ecology unit, right?
Hmm.
Okay, so the makeup air handling unit can give you 85% of the airflow what is required inside the space, and the kitchen ecology unit can give you 100% of the airflow rate what is required inside the space.
Okay.
Okay, so this is the way you can calculate all the kitchen ventilation requirement for the each and every appliances. One of the calculation sheet I will provide you where you can see, you can provide your appliances reference. Then you can add your type of appliances, size of the appliances, right? Then
Yeah.
quantity, then types, whether it is a gas or electric, and the area. You can calculate appliance coefficient from the table, and you can calculate the canopy factor, right?
Yeah.
Okay.
But can I
So
ask you something here, Parni? So
yeah, yeah,
basically, for example, the coefficients that you were saying, the appliance coefficient, the canopy factor. The
yeah,
canopy factor would be common depending on the the number of. For example, in one you have one hood, so that entire hood will have the same canopy factor, right? Correct me if I'm wrong.
yeah, yeah.
Yeah, right. So, for example, we have like in the example that you've showed in the plan where we had like three sets of hood. In that one hood is what is MK-01, correct?
Okay, okay, okay.
Yeah. So all of the canopy factors would be still 1.35, correct?
Yes, yes.
Depending, it depends on the DW172, yes. And
Yeah.
this appliance coefficient, this can change depending on the size of the appliance as well, right? Or
No, this is appliance for the appliance coefficient is depends upon the type of appliances. Say for
okay,
example, if it is a bench, 0.03. If it is
okay.
sink, 0.15.
Mm,
If it is
understood.
Indian cooking range, zero point 0.4, zero point 0.4. So this will
0.4.
change, but canopy factor cannot change because it is a common for one set of appliances, right?
One set of appliances. But can you take me to DW172 if you have it with you?
Yeah.
Yeah. Yeah. So for example, now when we are taking this is the coefficient that you said. So do we have a bigger list for these coefficients?
Yeah, that is what I have shown you before. If you go on the top,
Okay, okay, this one, right? Okay, okay. Sorry,
yeah,
sorry. I thought it was
yeah,
only that. Okay.
yeah. So
So
from
we
here you
have
will
to
take
add
it.
this, right? Okay. Hmm.
Yeah, yeah. Clear, right?
Yeah, yeah, I think I'm clear.
Okay.
Yeah.
So then if you go to the Excel sheet, you can able to calculate the canopy factor. Okay. Then you can calculate the extract air requirement by using the calculations, right? By
Yes, yes.
multiply by area, multiply by appliances coefficient, and multiply by canopy factor, you will get the total extract airflow. Okay. So if this set of all this particular set of one appliances, okay, so you can calculate the
Mhm.
total extract for the total appliances.
Yes,
So for the set
yes,
of
yes,
appliances, what is the total extract air requirement? Okay, then you
yes.
can convert from whatever the unit you require. Then you can calculate safety factor if you need. Then you can calculate
Okay.
makeup air requirement, right?
Mm-hmm.
So when you see the
So,
layout,
but
yeah,
okay. So this safety factor is still something that we add as a rule of thumb. It,
this
it's
is a
not.
depends on consultant to consultant. Some consultant will apply 15 percentage. Some consultant will go
Okay.
with 15. That is actually safety factor depends upon person to person. Okay, so that is not a fixed
Okay.
value. Okay,
Understood.
when you when you
Yes.
when you when you are it is depends on the error. Okay, say for example if you
Mhm.
are expecting accuracy, say it's not error, it's the accuracy. Okay, say for example
Yeah.
if you know that the 100 percentage will be that equipment will be on board. Okay, so you can consider like
Yeah.
5% or maybe no need to consider any safety factor. Okay, but assume
Mm,
that
mm,
there is a major change is going to happen. Okay, so normally the
mm,
people take okay just for safety purpose take 10 percentage or 20 percentage, sometimes 25
mm,
percentage. I
mm.
see some of the consultant. Okay, so this is the way to calculate your total extract air and ventilation makeup air requirement for the set of appliances. You have
Mhm.
any doubts?
Yeah. So this is more like from schema. This is my question. Sometimes you have your kitchen consultants come on board only from schematic stage onward. So when you're doing your pre-concept or concept level calcs, how different will the calculation will be? Finally, just to understand.
Yeah, see, concept stage normally they don't do any calculations for the kitchen. Sometimes they do
Okay.
based on air change per hour method. Okay, if I go to
Okay.
DW 172, that is just for rough estimation. Okay, you cannot
Rough
apply
estimation. Yes.
exactly
Yes.
here. If I
Yeah. Yeah.
search air change per hour, let me search here. Yeah. Can you see approximately one of the kitchen where kitchen with all electrical equipment, air volume, okay, both you can able to calculate 0.939 meter cube per second, okay, and 40 air changes per hour, right?
Okay. Okay.
So some of the
Okay.
time they apply some of the air change per hour, okay. Even I
Mm,
can
mm,
go
mm, mm.
further. See some of the kitchen, okay. You can say that when setting algorithm for DCKV system, it is essential that the minimum background ventilation of 20 air change per hour is maintained at all times in the kitchen. Okay, a commercial kitchen where no cooking takes place is classified as preparation area, that is 20 air change per hour. So sometimes they
Okay.
calculate based on air change per hour.
Understood. Understood.
Okay, but
But
this
I think
again,
this factor still changes, right? Or
yeah, still it will changes. See, when you want to do for concept stage, okay, when you don't have any appliances in your hand,
yeah.
you can able to
Yeah.
calculate based on air change per hour method,
Yes. Understood.
ACH method. Okay, but that
Mhm.
is only rough estimation where you can do the estimation purpose. But when you do the actual ventilation requirement, will be based on depends upon the appliances, depends upon the type of cooking. Okay,
Yeah.
in that what is the size of the hood. So this parameter will change exact.
Understood. Understood.
Okay,
So
now you
yeah, because
can
this is just
yeah
more like because why I've seen this was because I had a project where we were doing the kitchen ventilation when I think it was in a concept stage. So I remember them using 50 air changes per hour for the main kitchens, and then
yeah
for the smaller kitchens they went for like 30 or 40. So I
yeah
wanted to know what was the reasoning behind it. So that's why I
yeah
wanted to
everything
know
as per DW 172.
172. Yeah.
Okay,
Okay.
if you read this particular document, you will understand. They will itself tell you that when you don't have any detailed information, you can able to consider
Yeah.
R change per hour method.
Okay.
Okay,
Okay. Understood.
yeah. Now if I go to again the same layout, okay, where you can see the makeup air handling unit, which will be like normal air handling unit. Okay, where you have a blower,
Yes.
coil, and filters, everything. Okay, but when you talk about ecology
Um.
unit, yeah,
Yes. So in the makeup and handling unit, it's basically like a fresh air, like it will have an enthalpy wheel and filters, enthalpy wheel, the cooling
no,
coil.
no, there is
No,
no enthalpy wheel will be there. Enthalpy wheel, if you provide enthalpy wheel, where it will take the energy.
latent load.
No, where it
Hmm.
will take the energy. So because here it is one way, right? You're not. It is
Okay. It's
not.
only one.
It's
Yeah,
not.
yeah. You're not taking it back or anything. No, correct.
Yeah,
It's
you
only
are not taking it
discharging
back.
it.
So
Understood.
you have a simple. You have a blower, then you have a fan coil. You have a cooling coil. Then you'll be
Cooling
having a
coil, and
filter.
then it.
Yeah.
Yeah.
So this temperature,
Understood.
when you talk
Understood.
about this
Sorry.
temperature, okay, this temperature will be assume that 46 degree from outside, okay, and where you want
Yes.
to supply at low temperature around which is like 24 degree or 26 degree, okay,
25
for
degree
the
plus or one minus one, right?
plus or minus one, right? Okay, for to maintain
Yeah.
because
Yeah.
fresh air you will supply. You're not going to cool the space, right? This is you're going to
No.
replace the exhaust air, okay.
Replace
So your
the
supply
dirty air.
temperature will be same as room temperature.
Yes.
Okay,
Okay.
so based on the delta T, you can able to calculate your MHU load, right?
Yes.
Okay, now the ecology unit comes in picture where you have all the exhaust, okay, and this ecology unit basically, if you go further down, okay, you can see this picture where you can see this picture here, right? The ecology unit consists of
Yeah.
blower, then you have a activated carbon filter module, electrostatic precipitation, HEPA filter module, then you have a pre-filter, back filter, okay, clear, right? Then you have a ESP access
Yeah.
door, carbon filter access door, fan access door, then pre and back filter access door. Okay, so carbon filter is basically to remove the smells. Okay,
Okay.
and electrostatic precipitator is basically to remove the uh, grease. Okay, like oil content.
Okay.
Okay, HEPA filter is to
Mhm.
minute whatever the particles which comes from your kitchen appliances. Okay, so that will be
Yeah.
filtered here. HEPA filter. It is like a
Okay.
minute micron
Mhm.
filter, right? So this is the way.
Okay. Yeah.
This is one of the equipment where you might have seen where you when you design the kitchen ventilation system where you design with the ESP electrostatic precipitator, right?
Yes. Yes.
Okay, so this is the equipment basically. Okay, so when you see the system, when you see the schematic diagram, where you can go with the one set of MEHU, one set of ecology unit for the combined hoods, right? And the kitchen ventilation,
Mhm.
which the kitchen will be maintained at 25 degrees Celsius plus or minus 1 degree, and then whatever the excess fumes or heat produced from the appliances will be taken out through the kitchen hood. Okay, we know how to
Yeah.
calculate the kitchen hood sizes based on the appliances, and we know how to calculate the exhaust air flow requirement based on the appliances and depends upon the canopy arrangement. Okay,
Yeah.
so when you sum of all the flow rate will be
All
added to
of
the
the hood flow rates, you get a total flow rate, which
total
would
flow rate for the
basically be
equipments.
your yes. Yes.
Okay, so this is the way
Yeah.
to design your kitchen ventilation and air conditioning system.
So